For performance of the Cotco-Chad Cameroun pipeline project, bringing together the companies ExxonMobil, Chevron, Texaco and Petronas, Amex Kabag set up rigorous management of the socio-economic and environmental constraints relating to site activity. These new parameters account for a fundamental proportion of the construction of a pipeline. The project director and his team manage these new activities in addition to the traditional construction activities from the Douala PMT, Project Management Office. Health, hygiene, safety, socio-economics and environment now form an integral part of a pipeline construction project. The Chad-Cameroun contract, which came into force in September 2000, foresaw the construction of over 1,000 kilometers of pipeline of a diameter of 30 inches, 750 millimeters, required for the conveyance of crude oil from the Doba field in Chad through Cameroun to the Atlantic Ocean. Amex Kabag, in partnership with an American company for the entire project, was specifically in charge of the southwest part of the project, between Kribi and Bibe in Cameroun. This portion of the work represented 421 kilometers of pipeline to be built in an environment which was at once sensitive, difficult and hostile. The pipeline crossed many tropical forests, mountains, over 15 kilometers of marshes, 7 rivers over 30 meters wide, and rocky zones which required the use of explosives. All this was accomplished in a hot and humid climate with abundant rainfall for 6 months of the year. To maintain the designated contractual schedule, the pipe installation works were carried out at an average rate of 1,000 meters per day worked. To accommodate the personnel required for the construction, faultless installation logistics were required, together with a permanent rotation of 3 life bases with a maximum capacity of 600 people. Camps remained in place for just over 3 months. Amex Kabag developed and established training courses for the personnel in the field of safety and health hygiene. A site of this scale requires training and vigilance at all times to protect the employees and the local population. The safety reflex and a spirit of responsibility had to be developed at all levels of the hierarchy and at each instant of the site's lifetime. To this end, the management team organized close coordination and cooperation meetings with the bodies of the country. Daily meetings involving foremen and managers were held to remind them of the dangers which may be represented by the handling of some plant and tools.
Il y a un accident qui s'est produit ici.
Thanks to the safety system established, a simple radio call could at any time and very rapidly trigger an emergency plan to cope with critical situations. A safety reward policy was established. The best toolbox presentation, the best driver, the best worker, or indeed the best example of taking of initiatives in the safety field. The figures speak for themselves. Only 1 traffic accident was recorded for over 30 million kilometers driven. Fortunately, only 2 accidents occurred during 7 million working hours.
Le virus du sida est très dangereux dans le corps de l'homme et il est très fragile en dehors du sang de l'homme. C'est pour ça que même s'il est dans le sang de l'homme quitte le corps et rentre chez le moustique, il ne peut plus vivre longtemps parce que le moustique transforme le sang de l'homme.
In the field of health and hygiene also, cooperation was necessary with the country's health institutions, notably in order to be able to investigate, prevent and fight endemic illnesses such as sleeping sickness or malaria, and to sign collaboration agreements with the national and local hospitals. 35 national doctors were trained in emergency situations and 15% of the personnel in first aid. A program to prevent malaria and vaccinate against meningitis, tuberculosis and onchocercosis was established. Information campaigns were undertaken on waterborne illnesses, illnesses spread by contaminated food, and on sexually transmitted illnesses and AIDS. Condoms were distributed to the entire personnel. Pre-construction activities confirmed the environmental fragility of the sites which we were to cross, notably in tropical forests. The potential effects of our work were identified, and a list of precise directives was sent to the construction team concerning sensitive animal and vegetal species, archaeological and cultural sites, and the properties of soil when subject to erosion. To prevent soil erosion and to restore the biosystems, vegetal earth was carefully skimmed off and stored during construction of the pipeline and then replaced after the levelling of the work site. But until the vegetation had grown back and improved the resistance of the soils, measures were taken to cope with poor weather. It was thus necessary to erect sedimentary barriers, to dig drainage and rainwater regulation ditches, and build dispersal dams and anti-erosion covers. Revegetation was undertaken, sowing grasses and replanting seeds and young shoots of local trees from nurseries, which the Environmental Department of Amex-Kabag put in place, assisted by the University of Yaoundé and the Cameroun Ministry of Forests and the Environment. In addition to the partial and selective replanting of the worksite and under our sustainable development policy, 100,000 fruit trees were distributed to the nearby population, and several reforesting campaigns were conducted in partnership with the Cameroon Environment Ministry and the urban communities. For the fauna and flora, special procedures were planned to guard against poaching, trade, consumption of bushmeat and the use of medicinal plants. Several special units were formed. A water team with portable laboratories was responsible for managing requirements and monitoring of water tables. Using these measures, camps had no impact on the environment and could use their own drinking water and wastewater treatment units. Another team specialized in the management of accidental spillages of hydrocarbons and the decontamination of aquiferous soils and surfaces. Finally, waste of all kind was managed by special decontamination, sorting, recycling and incineration teams. The construction of the pipeline enabled economic opportunities to be created, assisting the development of local industries. Over 600 Cameroonian companies worked on the project. This project also encouraged the creation of small companies. Several cooperatives for the production and distribution of fruit, vegetables and fish were created, and mobile restaurants developed to serve lunch to the site workers on the track on a daily basis. An abattoir complying with European norms was even created. An employment policy based primarily on hiring of the local population through public information meetings in the villages was undertaken along the entire route of the oil pipeline, incorporating protection and inclusion of the populations encountered, including pygmies. These meetings were also used to broadcast information concerning health, MST, AIDS, etc., safety, proximity of plant machinery for children, and raising of ecological awareness, bushmeat. With the assistance of the Ministry of Employment and of the unions, an establishment agreement was signed to institute a climate favourable for the preservation of social peace during the construction phase. 7,700 Cameroonian citizens were thus employed. Even in the few reputedly difficult regions along the pipeline route, good coordination between Amex-Kabag, the local authorities and the client, developing regional compensation projects for the populations, allowed the work to be undertaken satisfactorily. The pipe was built in an essentially conventional manner, and the main difficulties lay in the land and the climate. After the marking of the route, the first task was selective and very limited deforestation in virgin forest, reduction of the working area. The number of access points to the site had also been limited in a spirit of environmental protection, which increased the difficulty of ensuring the safety of the tree fellers. The topography of the land was carefully studied by a team of geologists before the start of construction. Special arrangements were necessary to cross rivers and railways and zones in rocky or marshy terrain. This phase was followed by the following operations: skimming and storage of the vegetal earth, profiling of the work track and construction of additional access points, panelling of the steel tubes with a single length of 12 meters or twin joints of 24 meters was undertaken with special equipment and fitted with adequate protection to prevent damaging the coverings of the tubes, which were often transported under conditions of difficult access and chaotic traffic. The cold bending was undertaken by ourselves on the basis of the calculations of our specialist flexion engineers. The use of L's hot bent in the factory was also necessary given the uneven profile of some of the land encountered. Welding of pipes made of X70 steel required fine adjustment by our engineers and our QC department to guarantee quality and production. The welders were highly efficient both in terms of quality of work and in production, with a daily average of 90 welds and a rate of repair of under 5%. Two teams worked simultaneously, one on the main section and the other on special sections, special points, concreted sections, etc. Each weld was subject to a strict quality control and checked using X-rays. The coating of the welded joints was applied by a specialist subcontractor, thus guaranteeing that the pipe was uniformly protected. When the pipe was laid in the bottom of the excavation pit, a new quality control was undertaken with electric brushes, which detected the smallest coating default. The excavation laying was undertaken using special heavy equipment fitted with rolly cradle, so as not to damage the coating. The laying bed and the backfill of the trench were undertaken with fine materials selected either from the excavated earth by sifting machines or from the nearby laterite quarries. An HDPE duct, which was to be used to house a fibre optic cable, was also installed very carefully in the trench. Assisted by the research and recommendations of our environmental protection team, our restoration teams finally reformed the contours of the land and replaced the earth displaced at the start of the work, so as to return to a configuration identical to or better than the original one. This work also included all measures for protection against soil erosion. All our engineers had then to do was to undertake high-pressure hydrostatic tests of the pipe, the final quality and safety control before the installation was filled with crude. Simultaneously, the optical fibre was inspected to guarantee the quality of this communication resource.
Yeah.